And want to introduce my next presenter, Rahul Mehta. Rahul is with Theorem LM and also on the ML team on the infrastructure. He's the infrastructure lead, and we'll see Rahul go over Theorem's implementation and use of Flyte for model training workflows, also in context with Bazel. So that's going to be very interesting. So I look forward to learn a little bit more about this. We have about 20 minutes. So just want to make sure we can tailor it towards the last 22 minutes. Rahul, please, the stage is yours.
Thank you very much. Let me share my screen. Okay, just a moment. Can everyone see my screen okay? Wonderful. Yeah. So thank you very much, Martin. And thanks very much for having both of us. So yeah, my name's Rahul Mehta. I lead ML infrastructure at Theorem. And yeah, like Martin mentioned, I'm going to talk a little bit about how we use Flyte at Theorem for model training and back testing and a number of different workflows that support our quantitative research team. And in particular, sort of maybe a unique feature about our code base. Basically, we've been using a monorepo with Bazel for quite some time. So a big part of figuring out how we were going to deploy Flyte and integrate it with our existing systems was figuring out how to support it in that context. But first, I'll give a brief overview of what we do at Theorem. So Theorem's a technology company that basically sits at the nexus of consumer lending and machine learning. So we, as a company, have permanent capital across a couple of funds that we raise from, typical kinds of investors, pension funds, endowments, things like that. And we use those to help basically sit behind a number of consumer lending platforms and help fund and originate loans for them. So since 2014, we've acquired over 8 billion on consumer loans on behalf of our platform partners that we work with, and are continuing to deepen our relationships with them, providing opportunities for lenders to get into potentially new asset classes and to basically be able to improve on their underwriting with the sophistication that our models provide. So just to add a little bit more color to that, we basically have 3.6 billion in assets under management across 3 sort of main funds. We see, about 3.7 billion of annualized loan volume across all of our origination partners. So these would be online lenders that are in the personal loan and auto space. And then also separately, a large part of our business is also issuing asset-backed securities and also helping many of our other partners perform securitizations and sort of like similar types of private placement deals. So to date, we've issued about just shy of 1.5 billion of ABS. And taking a step back here, I think one of the really interesting aspects is this has been a sort of maybe a somewhat legacy space for quite some time. In the last several years, a couple of other companies have also emerged sort of with a similar intent of trying to apply machine learning and sort of like statistics principles to basically underwriting these types of loans. Obviously, in probably the more simplified case, a lot of underwriting can happen effectively with just a couple of data points. So think about, your credit score, the number of open loans that you have, your debt to income ratio, and similar characteristics like that. However, at Theorem, we make use of many more data points. We can take in both a lot of data points from credit bureaus as well as other alternative data sources, and really incorporating these into our models and improving the quality of underwriting and expanding sort of the set of individuals that we can actually consider to be creditworthy is one of the fundamental goals of the firm. So now would love to dive into some of the specifics about model training at Theorem. So across sort of the different asset classes and lenders that we work with, we have about 3 sort of core model architectures for predicting various features of loan performance. We have 6 domain-specific types of models to model various facets of loans. So, for example, the cash flows that will come in after a loan has been originated and someone is making a payment, other aspects around that. We have 30 distinct variants of our core models some of them for specific lending partners that we work with, and others in other domain-specific use cases. And I'll come back to this because this is probably one of the most interesting points of complexity that we've encountered with Flyte, basically where we have a number of very similar model architectures and tasks and workflows that we would like to use, but training them on vastly different data scales. And that's been a pretty interesting challenge. And just to sort of underscore some of the data scale challenges that we also hit up against, we have 40 million loan records in our data warehouse, and across all of them, over 50 billion historical data points on performance and credit attributes from borrowers that we use from our model training. To maybe add a little bit more color also to the sort of scale that we need to be able to reckon with and manage as an ML infrastructure team, we have over 60 daily scheduled model training and backtesting runs that are sort of like on a recurring schedule that incorporate the latest changes from our research team. And the model training and deployment process doesn't stop at Theorem with the classifier or the regressor that we're basically building out for a particular use case. It also includes sort of the wrapping of all the business logic around that in order to actually turn the predictions from a model into an underwriting decision, an approval, or a decline with a potential explanation of why the decline occurred. So in order to keep all of those changes in sync, continue to ensure that they're most up to date in our production environments and facing our platform partners, that's sort of what leads to the very high cadence of model training and, frankly, quite a large load on our model training system. We also support our quantitative research team, who, as part of their own experimentation, will be running, over 30 to 40 sort of full back tests on the loan level, with loan level history dating back to 2008 to validate various model changes, different experiments, trying to ensure that models have certain characteristics. Obviously, this sort of iteration has become crucial given current market dislocations and where with the interest rate environment where it is today. Supporting quick iteration for our research team in order to try a multitude of different ideas and be able to ship them safely into production is one of the things that we believe is extraordinarily important for Theorem at any time, but especially in today's macro environment. And just to add a little bit more color to that, from the orchestration side, some of our back tests, that have a fan out going back, thinking about a quarterly back test from 2008 to 2022 for some of our oldest data assets. These workflows wind up having somewhere between 900 and 1,000 unique stages, aka unique pods that need to run as part of our workflow execution. So scaling this up has been a very interesting challenge. And on the next slide, I will briefly go over sort of how model training at Theorem has evolved over the years, especially given as our data asset has increased. Hopefully this will add some color. And Katrina, I was really interested that you also mentioned that you had included Kubeflow in your evaluation of different model training systems. And we've definitely also had some interesting experiences with Kubeflow and other orchestration tools. So would love to go over those briefly. So originally, and I think what I didn't include on here is prior to 2018, we had a sort of very legacy Airflow-based model training system. But the first system that, I especially encountered, even some of the remnants of when I first joined Theorem, was our legacy Argo workflows-based training system. So we basically would think, previously to prior to this, a researcher would basically request a very large EC2 instance, would upload their model training script, run it, and wait for the job to finish, and then save a pickle or some binary of the model to S3 for future use, along with some validation metrics. When we encountered scaling issues with that, the first candidate here was basically packaging that model training script in a single stage of an Argo workflow. And this had some very appealing characteristics from the side of it being self-serve for our research team. So I think, like others have alluded to, the two things that I think you kind of always hold in tension with ML orchestration is the scalability and stability and security and all the other concerns that are primarily held by the ML infrastructure and the rest of the engineering team. And separately, the other aspect that it's kind of tough to hold in tension is ensuring that that system is self-serve for research. And Flyte has obviously helped us a lot with that. But in the legacy Argo training world, researchers would simply, they wouldn't have to touch any of the orchestration or the infrastructure pieces. you would simply basically implement a particular interface, implement a particular abstract base class, and implement a train and predict method. And once that was the case, so long as your model conforms to this particular interface, we can package it up in an Argo workflow and run it in the cluster. However, this was extraordinarily inefficient. And basically, it was replicating the same sort of deal that basically when researchers were spinning up their individual EC2 instances. The only difference now is researchers weren't tied to a particular EC2 instance, but the cluster autoscaler would wind up requesting a similarly, large instance, like an R5 16x large or kind of what have you. And one of the issues, that we really began to run into is that in our model training pipelines, we have certain stages which are extraordinarily memory intensive, but then we also have other stages like training, for example, like GBM model that are compute intensive. And of course, there are different appropriate instance types, different kinds of resource profiles you would like to run those different workloads on. But the, sort of a tough aspect of the Argo training system is we needed to request both a high memory and a high CPU node. And this wound up becoming quite costly and also slowing down research iteration. So next, the obvious choice then is to basically break up that monolithic training process into multiple stages and be able to orchestrate them as a DAG and be able to basically schedule the different types of workloads on the appropriate instances. So sort of in 2020, 2021, we started moving towards Kubeflow. And at that time, it was sort of one of the best options that we found. It was before my time at Theorem, but I think, the main goals basically here sort of still stand. So using the Kubeflow DSL, it's possible to express different stages of our training pipeline, in different pods and have different resource profiles attached to it. However, I think maybe like others on the call have seen with Kubeflow, we found that the Kubeflow DSL is extraordinarily cumbersome to work with. Most importantly, it isn't self-serve for research to understand, especially in sort of the 1.0 world of Kubeflow, where you still need to also define a corresponding YAML specification for your component. And also, we encountered a ton of scaling problems with Kubeflow, especially in these really large backtests. So earlier this year, a couple months ago, so I think maybe about April, we started investigating Flyte when we hit some of our real, sort of big kind of issues with Kubeflow that were blocking kind of mission critical model training and backtesting jobs for Theorem. And we've started investigating Flyte as an alternative. And obviously, as others have said, workflows and tasks are simple Python functions with far less overhead and boilerplate. I think I've mentioned to maybe some of the other union folks that we were able to reduce the amount of boilerplate by something along the lines of 85 to 90% for many of our workflows by simply migrating them to Flyte. Some of the other pieces that I'll maybe touch on right at the end is that modifying resource requests between launch plans, going back to the kind of aspect of our training system that I described, that we have a couple core model architectures, but we train them on very wildly different data scales. It's very difficult to do this without basically relying almost exclusively on dynamic workflows in Flyte, and which I think also leaves a little bit to be desired for us in terms of the type checking sort of at build time as opposed to at runtime. But we'll circle back to that later. So yeah, I briefly touched on this, also being cognizant of time, I might jump over this one, but basically in migrating from Kubeflow to Flyte, we've seen a ton of benefits. I think basically all of the other aspects that we've already talked about, including componentizing the training process, authoring simpler tasks and workflows, but more importantly, that multi-tenancy and security are really first-class concepts in Flyte. And also, certainly not least at all, the fact that Flyte is actively supported and the team is willing to accept upstream contributions is one of the biggest aspects for us in moving towards Flyte. In our initial deployment, we've encountered some issues with the UI, or want to register a particular type of type transformer and change the way that the compiler actually works. And the team has been extraordinarily receptive to accepting those upstream contributions. And that's something that we really feel that confident in making this investment long-term, especially because of how active the community is. So just to also add a little bit more to this, one of the other very big aspects of Flyte for us, and something that notably is not supported in Kubeflow, is the ability to actually do sub-workflows or proper workflow of workflows support. So For our model training and backtesting pipelines, obviously the ability to have code reuse is fantastic. Also, it means that for our researchers, so long as we have sort of like a skeleton backtesting pipeline that accepts a training sub workflow with a particular interface that they can implement, it's far easier to get a backtest stood up if they just simply write the couple of different stages in the training pipeline that they need for any new model that they're iterating with. So to close off that section, that's our basic overview of our usage of Flyte. But now wanted to talk through sort of a unique aspect of our system at Theorem, which is, we are in a Python monorepo across our entire organization, and that spans the data engineering team, ML infrastructure, research, as well as our API and model serving sort of layer. And all of this is in the same monorepo, and we use Bazel to manage this. So a brief overview for folks who haven't seen Bazel before. It's a build tool with similar goals to tools like Make, Maven, and Gradle. It allows you to declare targets and build files in a high-level build language called Starlark, which is basically a derivative of Python. But most importantly is it maintains the state of the build DAG and enables fast and correct caching for complex builds. It also has support for multiple languages and tools, so Python targets, container images, Kubernetes resources, and things like that. The third point is sort of the most important one here, given that the fast and correct caching enables, over the course of development, when a user makes a change or touches a particular file, we only will rerun tests, linters, and rebuild container images, things like that, for only the affected targets, sort of in the kind of transitive closure of that particular entity that you're working with. So especially in monorepos, rather than needing to rerun your whole world every time and it's slowing down both local dev experience and CI, we're actually able to rely pretty heavily on Bazel's caching in order to achieve some of these goals and improve the developer experience with the size of our existing monorepo. Basically, so also if you're not familiar with Bazel, this is sort of what a similar, or basically what an example Python library target might look like. So suppose we have a utility module called cacheflow tools, and basically you can specify the sources for it, any of the dependencies, other utilities in the same package or in your same repo, or external like pip requirements like pandas, numpy, or scipy. Similarly, you can declare tests, and the PyTest wrapper will automatically run it with PyTest, and also will basically automatically set all of your linters and formatters and stuff up for every target. So now that we have gone through Bazel a little bit, coming back to our integration with Flyte, a core aspect of this is that since our entire system is declared in this monorepo, we needed to also provide an integration for Flyte to make it seamless to use in our existing setup. So we authored a new set of Bazel rules called rules Flyte. So in our build file, we're effectively able to declare a Flyte library for a particular model. We can include a particular workflow and include launch plans across multiple files, as well as specify all of the dependencies. So importantly, these are really simple to author for people who have already been in our system. And also it forces you in the development experience to be very thoughtful about the explicit dependencies that you're encoding here. Obviously, this may seem like this is a little bit of overhead from the perspective of researchers, but that said, we have some tooling that can help automatically infer the dependencies and help basically fix up this build file, even if you aren't manually encoding all of it. The important part here that I want to underscore is that we can use the same built-in targets to build our image and register workflows in both experimentation and in CD pipelines. So the fact that this is one-to-one is really good for reproducibility and just kind of in general having a sense of sanity across both our experimentation environment as well as when we're deploying production training and backtesting workflows. The final piece that I wanted to touch on here is we have also made some really interesting improvements to how we actually build the container image for Flyte workflows. Using a feature in Bazel, basically their Docker build rules called fine-grained layering, we're able to basically ensure that our dependencies, that we can basically construct explicit layers in our container images based on the different sections of the Flyte library here. And based on Bazel's caching, using this fine layering, we're able to get the incremental build time for workflow and launch plan changes to basically under a minute. And what this enables us to do is properly rebuild the image every time and push it, which in our mind gives us improved safety and reproducibility over fast registration, and also just means that we have one fewer, we have one less distinct process to support, and there isn't a bifurcation between researchers iterating on model changes and actually the same way that we build and deploy them in production. So I'm happy to touch on that if any folks have questions at the end, but some of the basic things that, where do we kind of go from here? We have some UX, we'd love to make some UX improvements, like making it easier to identify users and tagging in the UI. Also, like I alluded to, basically being able to support resource overrides outside dynamic workflows, given those particular kind of constraints around one or two model architectures, but very wildly differing data scales for the different lending partners that we will train models for. Also, improving integrations with MyPy and other build tools, as well as being able to actually more deeply integrate Flyte workflows and launch plans with our GitOps infra. So overall, though, we are really thrilled with how Flyte has panned out at Theorem. On a go-forward basis, we are implementing all new model training pipelines in Flyte, and the migration to backfill the existing models that we have in Kubeflow is ongoing. But we're hoping to have our full cutover achieved by basically Q1 next year, and then kind of turn it over to research and kind of let them have at it. So thank you very much for the time. Hopefully we have maybe time for one or two questions, but yeah, turn it back to you, Martin.
Yeah, absolutely. Hey, Rahul, this was fascinating, amazing. Love, how you actually accelerated the build time of the images with Bazel and so on, and be super nimble. So let's see if we have one or two questions here in the audience, maybe Niels or somebody else.
Yeah. Can you hear me? Okay.
Yep.
Cool. Yeah, just a quick question on the overrides story. Is there, I know there's the with overrides task method.
Yeah.
What would make, what's the UX that is ideal for your team?
So one of the few features that we actually did like about Kubeflow is the concept of an op transformer that you can register with the Kubeflow compiler. So the idea is that, I have a Kubeflow workflow, I can compile it, compile my workflow function. And then there's a post-processing function you can define that basically will just provide you a list, and it'll basically map over all of the tasks there, and you can apply an arbitrary transform to it. So the way we did it is we included a particular annotation in that. When we would see that annotation, we would basically swap it with a resource profile configuration for a given data set. Now, obviously, the other approach here, which we're also considering, is making our tasks be able to kind of horizontally scale, thinking about, building deeper integrations with tools like Spark or Dask for various stages. But this one feature, I think, would be pretty important for us. And something I've spoken with other folks like Keithan and Eduardo on the team, we would love to be able to get around to either helping spec out an RFC or helping make this a reality. But, something akin to Kubeflow's op transformers would really be sort of like the high watermark of the UX we'd kind of be looking for here.
Awesome. Yeah, let's follow up offline about that. That'd be really cool to support.
Okay, do we have another question? Probably. Well, we can follow up offline as well in the Slack channel. Rahul, I think your numbers about the boilerplate code that you saved from moving from Kubeflow to Flyte are already legendary here within the engineers on our side. So I heard about the savings already a long time ago. It's fantastic. So what would be potentially wonderful is, follow your journey and see, where it takes you, and have you back potentially in Q1, Q2 next year. Also, what I would love to potentially follow up with you is maybe we can actually cover and capture your Bazel build system a little bit more, have maybe a blog post or something to that extent, and can share this with the community. That might be very interesting. But I just want to say on behalf of the community, thank you so much. The team is super excited. Also, Keithan and Eduardo here on the core Flyte team are always super excited when they speak with you and then come back with feedback. So we love working with you, and we look forward to your next steps in the journey. Thank you so much.
Thank you for having me.